This story that I will tell is a summary of kind of 10 years from kind of undergrad onwards of dabbling in the field of reinforced concrete education and acknowledging and celebrating the people who have taught and mentored me to help me to where I am. So starting off with my students with their ACI 318 codes, all smiles, and this is like the last day of class, so we know that a good semester that went well. So I want to focus on 4 themes, and I actually use my students' feedback from the many times that I've taught at Cal Poly, our reinforced concrete design code, of what they highlighted as effective in the course. So the first is visualizing, and that comes in 2 forms. One is creating physical models, and then also setting up a set of incomplete or skeleton notes in a way that helps them create a concept map. Programming, so predominantly using a tool like Excel, so they can leverage computer software to create their own design tools that implement ACI 318 code-based approaches. Storytelling, the focus is twofold: one on highlighting the individuals that have impacted the code, but also the case studies. And I always focus on earthquake engineering. We're a West Coast school. The case studies that inform our design provisions. And the last focuses around experimenting. So for our students, that's the whole process of designing, constructing, instrumenting, testing, analyzing structural members to observe their response. So I want to set the stage with who my teachers and mentors were. And I'm starting at NC State, and actually I had the pleasure of having a PhD student teach my reinforced concrete design class. And that, I think, was the first time that an instructor of record was a student. And that really inspired me that one could go down this route of still being a student and having a class with, 40 plus students. And what I really admire about Dylan is I had a lot of questions, and this was his first time teaching, and he taught me how to be a compassionate educator, to realize that that's the first time that student has seen that topic. They are curious, and to embrace that and to seek out resources to really help them run with that curiosity. Chad, I have to acknowledge, because he was kind of the PhD advisor of large-scale testing research that I did in the laboratory at NC State immediately after I had graduated from NC State and was transitioning over to the University of Illinois. And he just had this passion for large-scale reinforced concrete testing around seismic engineering. He was the type of person that his after-dinner reading was technical papers on reinforced concrete. He kind of lived and breathed concrete, and to work with him, tying rebar, pouring concrete, analyzing structures in, commercial software, implementing FRP retrofits to fix very broken bridge columns. He was a real inspiration on the how do you become a research mentor and use that as a venue to teach. And then, of course, I have to acknowledge the 2 faculty that brought me into the lab. Mervyn Kowalski and Rudy Saraceno. So they were instrumental in my time at North Carolina State during my undergraduate and kind of transition into graduate school. And then there's so many people to thank at the University of Illinois, but I kind of had to narrow it down to a few. And I know Soam is actually here with us today, so that makes me very, very happy. I am proficient at reinforced concrete and teaching it because he was the one who had done it before me and kind of mentored me in how to be a good teaching assistant for our advisor, Dan Kuchma, who taught the first level reinforced concrete class many a time. And also when I was taking my further reinforced concrete classes at the grad level and balancing that with a pretty rigorous large scale testing schedule, he's the one who kind of showed, again, compassion and answering all my questions and helping me build confidence in reinforced concrete design myself. So I think what I'm trying to highlight too is that it's not just faculty that will be your teachers and mentors, it's your peers, and they are so, so valuable. I do also want to thank Chris Hart, who taught me a lot of kind of tidbits so that I could be successful in large scale testing at Illinois. and my research partner who did the same. And then, of course, all the faculty that were on our large-scale testing project. And I learned tremendously through doing experimental testing. Outside the classroom, I think, has a really big impact on students. If you can get them engaged in experimentation of things that actually have impact on the codes of practice, I think the students are drawn to that and can really apply themselves. And that's the arena where I really grew. And then, of course, I have to acknowledge Don and Laura, co-PIs on our project, but more importantly, advocates for underrepresented engineers, continuing on with a PhD. I think it was their strength and confidence that really had me kind of, you know, overcome a lot of things, stick with it, and end up where I am today. So I think teaching is also about mentorship and building confidence in your students and guiding them, because there are challenging times and we need to learn how to be that support system. So these are the folks that kind of um, helped me along the way. So I want to provide some examples of kind of pedagogical interventions that I did in the reinforced concrete class at the University of Illinois. I indicated that I was the teaching assistant for our reinforced concrete design class for the undergraduates, I think 4 or 5 times with Dan Kuchma, my advisor, before I actually became the instructor of record in spring of 2015. And as soon as I got that opportunity, I had already had in my mind all of these concepts that the students had difficulty visualizing in 3 dimensions, including, linear to parabolic to the equivalent stress block. How do we deal with non-rectangular beams when we have, enough reinforcement that at nominal moment that we're actually getting into the web of the cross section versus just in the flange? Students tended to default to doing positive moment analysis even when it was a cantilever beam. So I made sure to make a model that showed them when you're dealing with negative moment, your compression zone is not on the same side. So these were simple styrofoam models that I designed and fabricated myself in the student shop at Illinois. And then things got a little bit more complex. I wanted to make these plexiglass models that you could draw on with a board marker that you could ask students to label the spacing and the your D value from the extreme compression fiber to the centroid of your tensile steel, that you could kind of play with different rebar sizes and different spacings of your stirrups, because this particular class at Illinois did not have a fabrication component where the students would make and test beams. So the thing about concrete that's so different from other materials is you can look at a concrete beam and not understand what the rebar configuration inside of it is. It is kind of hidden, right? As opposed to like a steel beam, you can look at it, you can tell the flange thickness, you can tell if it has plate stiffeners along its web, things like that. But concrete, it's like you can see the exterior dimension and you don't have a sense of what's going on inside. So I felt this was really important for the students to get that 3D perspective of what it meant when we were doing flexural and shear design. So this was kind of the piece de résistance, if you think of it that way. I designed, and our shop personnel were just so generous with their time to build this model. It's a one-way slab model. Everything is color coded. You have your positive and negative reinforcement in your slab. You have shrinkage and temperature steel. You have your beam flexural reinforcement with a hooked anchorage. You have your, column ties, everything. And this, again, is something that you can just draw on with a board marker and explain to students how this kind of connection detailing works, and ask them questions like, hey, is it actually efficient that we space this stirrup rebar at an even spacing the whole length of the beam? How could we make this even more efficient design? So this, I think, was really helpful to the students. And when they were doing their end of course projects, they were like, can you bring the model out, because we have to detail our columns and we're having trouble visualizing how everything fits together. So I did end up publishing this in September 2015 in a Concrete International paper. So if you have interest in kind of the details of all that was done while I was the instructor record in grad school. You can take a look at that. I also did surveying and interviewing associated with that study. So I kind of made it into a full-fledged IRB approved human studies project to assess kind of this intervention with the models to see how it impacted the students. And I also want to point out that we need to think outside of the classroom and beyond the undergraduate student as our audience. So I did get engaged while I was at the University of Illinois in a residential summer camp that lasted a week called Discover Engineering Summer Camp with high school students. And we actually did teach them about earthquake engineering and concrete shear walls. And so here's a student with her formwork for the shear wall. We'd given them like the crack mapped from Vector 2 results, which is a it's a open source software. And so that gives them an idea of where to put their tension reinforcement and things like that. And so I was just providing some advising, and she was proposing some solution to the design problem. We mixed concrete, and then we tested once the specimen they had created had cured, we tested it in our 1/5 scale laboratory that we actually do use for research as well. And what I want to point out here is that at the same time, we were running an NSF REU summer program. And so this student here, Amory Martin, that you see with the orange bucket, and this other student in the back were our REU students who have been doing technical research with us, but we engaged them in outreach as well, which I think is a really important learning experience for them. And then the other thing I got involved with was actually teaching beginning educators in the K-12 system in Illinois. So our university actually ran like training sessions that they would invite beginning teachers from all over the state to get exposure to STEM education. So I actually set up, some Pasco sensors and showed them how we can use the data acquisition with a simple foam beam and start to understand the idea of compression and tension and reaction forces in these supports and things like that. I also did the typical concrete thing to do, which is hand someone 2 pieces of styrofoam, one with a piece of tape and one without, so they could experience themselves that if you have no tape, i.e. no reinforcement, you're going to have a brittle failure. And if you put tape on one side, you will get a ductile response. But if you flip that same beam over, you can get a brittle response if your tension reinforcement is on the wrong side of the beam. So that was very illustrative to them. And then we also have the fortune of, we do actual research in that 1/5 scale setting. And so this was a similitude column that one of my PhD colleagues had made for his research, but it's small enough for me to carry around and take to the STEM conference and show them, like, here's what it looks like inside of a reinforced concrete column, and talk about how it fails in an earthquake. So I think what I want to point out here is that our audiences can range from pretty young, aspiring potentially engineers to educators that work with K-12 students. So to transition, moving on to Cal Poly, where I started in fall of 2016, I want to acknowledge there the many collaborators and mentors that I've had who have influenced either my concrete research or concrete teaching in the classroom. So I'm going to start with kind of probably the simplest thing, low-hanging fruit in terms of how can we help our students learn. And a lot of students said it was the organization of the notes that really helped them learn. So you'll notice in my notes, I'm pretty big on indicating exactly what section of the ACI code and section number. And the students, as you saw in the very first picture on my cover slide, all of our students actually get a code, and we have a donor that is very gracious and donates all of those codes, so we hand them out to the students. So every time we run into one of these highlighted bits with the code, I have them go over to the code and highlight it physically in the code, take a look at how the language actually appears rather than just seeing it in my notes, go back in and tab it with their colorful tabs. So this is kind of like giving them a sense of the connection between what I'm describing in the code. And then also the skeleton notes helps because it's about laying out a procedure and then indicating what if our steel didn't yield? What do we do then? So that's how I see concept mapping, is that you're pretty procedural in how you lay things out, and then you speak to them about, well, what if our cross section isn't a rectangle? What do we do? Okay, now it's a T section, but what if it's flanged in some way, or non-rectangular, but it's not a T section? How do we kind of transition from using what we know to some new application? So I just think the skeleton notes have been something that time and time again, they've indicated as part of their success in the class. Another thing that I've done with them is actually developing Excel tools. So with the Excel tools, I kind of give them a screenshot of how my Excel tool ended up looking like, because a lot of them haven't seen Excel since high school and frankly don't realize like how powerful this is. So I teach them that you can rename all your cells based on, variable names that we actually see in the code, that we can develop nested if statements to calculate our beta 1 factor or our phi factor, that we can do conditional formatting to make sure our steel has yielded or that our AS min check has been completed and it turns green or red, that they can conduct a VLOOKUP, which means that they can have a pull down menu to select the bar size and it'll automatically go into this table on the side and pull the right diameters and areas, and so forth. So there's a lot of things there that they've walked away and said, I ended up using this in an internship, or every new calculation problem we did in class, I went ahead and made my own spreadsheet. So it seems simple to us, but when we show something to a student that's powerful, some of them really latch on to it. Storytelling can also involve you bringing in your own case study. So I did some research and study abroad over in New Zealand. So I always like to bring in, when we're talking about minimum reinforcement ratios, this example of a wall that had very low levels of vertical reinforcement that ended up seeing a bunch of bar fractures. So I connect that to the code provision about minimum reinforcement. I also was able to deploy 2 teams to Mexico after the earthquake. And so I used the blogs that the students wrote as material to supplement our reinforced concrete class, and had the students on campus kind of interact with the students that were abroad on the reconnaissance mission. Experimenting in fabrication and testing. We do beams in our reinforced concrete class. So I pulled a variety of pictures from bending rebar, mixing concrete, building forms, tying rebar, and testing our beam. So that's in the classroom. And then I also want to point out that research is just as much an opportunity to teach as the classroom is. And so you can see there's many, many students and faculty explaining stuff when we were doing a large scale wall test in our lab. Real quick, I want to acknowledge all of the undergraduate students who have done concrete related research with me and co-authored or co-presented work at conferences and elsewhere, and also the graduate students. So, it's all about mentoring a diverse range of students and building up their confidence and technical knowledge to go on and do great things. And then I want to remind us all that ACI has a lot of opportunities too for mentoring and getting involved in education. And so the ones that I've kind of picked out for myself as opportunities over the years has been S805, being a faculty advisor to that Student Leadership Council, being a voting member of SciPac, and now serving on the ACI Foundation Scholarship Council to help support the next generation of students. And then also there's the opportunity to do educational webinars, and I was really fortunate to have the opportunity to do a webinar moderated by Ann Ellis, but also with faculty Stephanie Paul and Erica Fisher. I think I've gotten pretty close to the end of my time, but just to give you an idea of where I think I'm moving forward and maybe some inspiration for where we all can move forward, is keep fueling that curiosity and enthusiasm that the students have when first encountering a new design material. Provide a range of learning activities so every student can connect with the topic. Different people, some people get really attracted to Excel, some people love fabricating things and testing them. So we just have to kind of find different touch points where we can connect with our students. Third is, I think the industry is advancing, And it's advancing in ways that we may not expect, in terms of we may be using machine learning to help us analyze, the column performance instead of just some formula from the ACI code. And I think we need to keep learning ourselves so we can track with where everything is going. And then lastly, this is more related to ACI, but continuing to develop opportunities for students to engage in the Institute to build their professional network, but also so that they can realize perhaps their dream of impacting the future of the concrete industry. So again, I just want to end with a thank you, and the people that make this all worth it, who are the students. And that's all I have for you.